optic, we expand the laser beam to a sheet, and this sheet is put it in this area, and so I turn the ventilation of the wind tunnel on, and now we cannot see anything because the laser light.
Это можно будет скачать?
Yeah, because the laser light scatters on walls and on the object. So we add some tracking particles to the flow, and now you can see.
This is smoke, yes?
Yeah, it's a smoke. This is olive oil droplets, and these olive oil droplets scatter the laser light from the sheet, and you can see the flow around. I don't know, the camera holder here, or the rear wing, and the movement behind, and the air behind, and these vortexes behind the car. Yeah. So this is very helpful visualization, which could tell you many things about your problem. But we use, as we look to this image, we capture this image also with digital camera, and made some analysis to produce precise data, the numerical data of the movement. So we can now go to the computer, and I will show you what's the result of this measure. Separated particles, not only the fog, but it's separated particles. And as I told you, this is the pulse laser. We cannot recognize that it's not continuous, but it's pulsing because there is 1 kilohertz of recognition rate, 1,000 pulses, and first pulse illuminates this image with these particles in the initial position.
Так не это, через камеру
It's like the stroboscope effect. And so we illuminate the particles, we stop them, record them, and then after it's dark, the particles move with the air, and we illuminate it with the second pulse, and we have the final position of the particles. So now we have 2 images, one with the initial position, one with the final position. Everything what is inside will mix only this way, and that's not sufficient enough. So they add these fittings to this tank, and you can see that now there is the movement with this way and also in the vertical plane. So that helps to mix to make sure the water more efficient. So, and we also measure this this experiment. They calculate all these data. You can see are calculated with a numerical simulation. That's very modern, and it's more cheap. It's cheaper than experiments. But you need experimental data. For example, in some regimes or small area to optimize the numerical models and also to verify them.
We'll fill with a special head then and put this material on the table, and we have 2 UV lamp. It's the material. This lamp is for hardening the material, because first put the liquid material on the table on the base plate and harden it with UV lamp. This machine is better because you can use a lot of materials. This time you can use about 100 materials, and 1 layer is 16 microns. It's still different because there we have 250 microns and here is about 16 microns. And the materials it's very different because if you can use high-temperature material, ABS line. This is material is very good. it's against like this. It's a very good material. It's the same like ABS. It's similar. And second, we can use transparent material. We use this material for automotive like Škoda car because we can make some parts for yeah. And some rigid material. It's very hard for. We use this material for company Continental, and in Czech it's Barum. Polypropylene, it's good for some like this, but we have a lot of students here, and this is the model for TEMPUS.
Maybe it will never fire. Well, English. This is about ERV 1014. This is about 114, and this is about 1400. Yes, and this is about 120 ERV all robots. These all robots are with angular kinematic structure. These all robots have 6-degree of freedom. They are classical industrial robots, which works in any industries and so on. This is the control system for this one robot, and this is much more smaller control system for this one robot. The weight of this robot is about 230 kilograms. This one about 100 kilograms, and this one is only 29 kilograms. The robot is much more for us. Here is American robots, robotics from United States. This one is classical skull structure. Classical skull structure. This is very often used in the electronic industry. And this is the classical angular kinematic structure, but it has only 5 degrees of freedoms. The position system has 3 degrees of freedom, but the orientation system has only 2 degrees. Usually robots are, for example, mobile robots or robot arms. Yes. Or there are one robot, for example, it has here a very small human robot. Yes.
This is Lego. Lego or more?
No. This is Bioloid. Lego is here.
What company produce such kind of robot?
Japan.
Japan. She's like Aibo, I guess.
Yes.
Just small.
Like Aibo. Almost the same way.
But to move it, what must do? What must do? Satellite.
Only very simple movement.
this we can make parts for that. But the principle is visible. Recent models are almost like a box, and you cannot see inside. So this is 60 years old from the beginning. Yeah, Berger. How to measure momentum? Yes. So you can measure momentum simple way. And for such old motor there is a control units, electronic control units, so here and there. It works still, yeah, 60 years. Other Barcelona cascade for controlling motors. Again, very undestroyable by students. So it is very good made measurement devices, not electronics, on the analog, and you can see the arm visible. Yeah, it's for basis of electro engineers. So there is an asynchronous motor with different kinds of switching processes, frequency converter, standard switches, D and Y by combination of winding. Another here is research. So one of my colleagues, he deals with the transformers, how to connect them safe way into power net. Because if you have an induction load, it makes current peaks, and sometimes it can destroy the line. If you have a very big induction load, and it can produce, of course, fire in such boxes under under specific conditions. So he analyzed for one company from Liberec, Svet, it is here, maybe yeah, Svet. They produce such devices. He makes for them measurement for models verification. So they produce such very simple and very well-known devices, but very well-known, but not so well described. Sometimes in the practice you use things and they are not described by analytic way. So they make models now by finite elements and so on.
this generator. So we can simulate energy generation, and this energy, electric energy, give it back to recuperation example. So here is a motor. There's a motor as a source of mechanical energy, and here we transform it again to electrical energy. And it's very nice. If you can see here, it's a complete electronic circuits, and these students, they have to study it to understand. Using it for engine. So you can see how does it look. So typical electronic control unit.
What system you simulate now?
Simulated a unit of braking. Braking.
Computers are with a measurement card, so we are able to connect any device to it and control it through the computer. The philosophy in many of the subjects is that we use the MATLAB software, which is on the level for the student education, and it allows us to implement and to try almost everything that is necessary. It's the advantage is that there's a lot quick in case if we want to implement the control to the real process. We are still in a short way some type of processing, because you saw it also tomorrow, because it's this laboratory is also the laboratory is the exchange program is Cital. So we have here two systems of DC motors, which are connected together with elastic flash. The boiler. In the boiler is down the heating spiral, and the power on the heating spiral is controlled by the external power source. And there is measured the temperature once more again by PT100 sensor of the water on the level, or water which is flow out from the heater. And the flow rate through the heater can be constant or controlled. So it allows us to increase the possibility of the control. That can be said that this process is multivariable. So two inputs and two possible outputs. Input as a flow rate, input as a power source, output as a temperature of the water, and the flow rate through the system. So good possibility to implement it to our lectures of a multivariable process controller. In the back, the circulation of the water is closed, so it's not necessarily some external source of water. And the water in the mass of these tanks is measured once with the pressure sensor. In the second case, is there also the pressure sensor or the capacity sensor. And the configuration through these walls allow us to modify the actual structure and actual aims for the control. So the easiest and the basic structure is that it's controlled the level in a tank, and the tank is in a separate control. So it's this connection between these two tanks is closed. This valve is open, and of course the level depends on the actual power of the pump. So for the system, is a measurement card. So finally, it's some block here in the software. And the process has some amplifier which change the signal to the right power signal. And in opposite direction, the signals which here represent, for example, the rotation speed is converted through some amplifiers to the software. In a basic course, it's only linear models. So therefore, it's necessary to find the working length and identify it only around the working point. So basic measurement with a step response on the input. Step input, and the output is with oscillation because it's elastic clutch. So. I think it's this is noise. Yeah, this is noise. Yeah, I will zoom it after the measurement. Maybe it's enough. So I zoom one of this response. So this is zoom. This is noise. So standard problem on all processes. So also students must catch and work with the noise. It's a standard part of all measurements. So therefore, communication with the card, the blocks of input and output, nothing else. And so the aim for the position in this axis is the red and the blue.
Laboratories that are used for control system courses, and its equipment is relatively simple because many courses that are running here are mostly of theoretical nature. That means they are then working on computers and using MATLAB. And besides, we have several simple physical models here, but quite simple. We use this model. This is, for instance, this is the model that is used as the controlled system in the real-time system course I was speaking about. Its structure is very simple. That means frequency converter and induction motor. The frequency converter is controlled by voltage from the input-output card in the computer, and this induction motor is loaded by this DC motor that is working as dynamo, and using these relays it is possible to connect either one or both of these resistors to it. That means it is variable load that acts as disturbance to control, and its rotational speed is measured using this small model. We have two pieces of this model, and it has a very simple structure. There is a rotating fan, heating spiral, and temperature sensors at different distances. That means it's basically first order plus delay response. The delay can be different depending on which sensor I use. The students are controlling the water level here, which is classically measured using this pressure sensor, and besides the flow rate of water flowing here is measured by this sensor. It has frequency output. That means it must be converted to voltage using this frequency to voltage converter, and the flow is controlled by this proportional valve. That means this solenoid valve, but not standard on-off, but proportionally controlled solenoid valve. That means it is then used as cascade control. This flow rate loop is the slave loop. This is the master loop. And besides, there are two possible disturbances. It is possible to change the outflow from this water tank by changing position of this electrically controlled valve. And it is also possible using this amplifier change the voltage at this pump, and in this way to change the flow rate to this water tank, even with the same position of this valve. That means this is used to model the input disturbance, because changing the voltage at this pump is actually input disturbance to the system.
From Siemens, the Siemens control units. And in the first laboratory, there are basic for bachelor studies, basic knowledge of motors.
The mixture of the ingredients, water and acids, they can simulate the temperature distribution in this reactor, and they can also simulate the pressure measurement and temperature measurement. It is all done there. We have the software like in Liberec, the MATLAB simulator. We can here see how the water moves. If I can. Or in this case, it's a vacuum, so the friction is very low friction.
Stefan, wat dan wil zeggen? Dat labor.
There's no friction. It's always a vacuum.
tasks, electrical tasks, we have to calculate it in 1.5 hours, and then the first and second and third place. We want to choose. We want to put people to our
genius genius one.
Students measure the humidity in the room, the atmospheric pressure in the room, and calculate the density of the air, and then have to calculate the airspeed with measure. One part speed measurement. Then we have measure the static behavior of this part. We have water in it and heat it to 90 degrees, and they measure the voltage or the resistance of the sensors. And then in this part we have a cold, heat, and warm vessel, 20 degrees and 90 degrees, and measure how fast the measurement is, the dynamic behavior of the speed sensor. And then control the level in this vessel, and it's in this part it's a nonlinear behavior, because there's another behavior in this part, and in this part, and this. So we also have the problem: do we use a PID controller or fuzzy controller, or switch depending on the level, different sets of the PID controller. But this is aspect is not in another level we can do there. We make the speed measurement and control. Then the fourth also in the other room we measure the behavior of walls of the quantum of such a wall. Are temporary here. The original is this part. We have we see for the photograph loop simulation. We can have different test systems with a different behavior, proportional, critical, differential behavior. Can measure or identify the system with especially with the MATLAB simulator software, and with it's from the firm G-Space, with a software where we can generate signals and measure the input and output of the system, and then also calculate we create a control loop, measure the system behavior connection. This here we can see mechatronic system of the lamp control. We have the sensors, the controller, the processor, and the actor. We can switch it on. It's a xenon light, and you have to in a usual car you have a manual controller to the level, control the level, but with the xenon light it must be done automatically. So here they have a sensor who measures if the lamp goes up or goes down, and then it takes the time to measure it, and then he controls there's a motor on this xenon lamp, and then he moves up and down. The behavior of the car, up, down, and uphill and downhill, and then he tries to build this 50 kilometers an hour. You also can measure the data from the accelerator, from the speed data, and program the controller. Here we have from the car an automatic balance control system. It's opened, and we can simulate the different signals from the four wheels, the speed of the wheels, and other signals, and see how the system works. We have different parts, for instance, the AFD and RBS and the lamps, they are also connected to a bus system and to a central computer, and I can listen on the bus what's with the car, what's the variety, once everything is okay, but we have an error in the central electronics, and so I can check it out, what's the problem, because we can create errors. In IT, for instance, I have a problem lamp for the blinking lamp. And it's, I have we have an integrated switch where we can disconnect different parts of the car. Where I can switch on an error and then see if the car.
You can simulate problem.
I can simulate. We disconnect the connection to the. I know. I haven't switched on the. So I get the information from the camera, and here it's a line follow program. Here you see there are on the floor there are the silver lines. He is programmed to follow this line. He checks with the camera the line and has a program to follow this. And now he tries to find